Lesson 2.5, Solving Equations Involving Absolute Value. Absolute value expressions. Expressions with absolute values define all upper and lower range in which a value must lie. Expressions can be evaluated using the given value for the variable. One thing to know with absolute value is that anytime anything comes out of the absolute value bars, it becomes positive. The reason why it does that is because when things are in an absolute value, it's showing distance from zero. So when we represent distance, we don't ever say that we're going negative distances. We're just going distance in the opposite direction and vice versa. So the first thing that we're going to do is we're going to evaluate, meaning we're going to take the values for x, y, and z, and we're going to plug them into the expression and solve. All right, so I'm going to go ahead and rewrite that. So 16 minus the absolute value of 2, and because we know that z is -4, I'm going to go ahead and put times -4 plus 1, and then I'm going to close out my parentheses. You might want to make sure that you really define where your absolute value bars are, because otherwise you're going to get it mistaken with the number 1. So I'm going to go ahead and go 16 minus, and I'm going to simplify what's in my absolute value bars. So 2 times -4 is -8 plus 1. I'm going to continue to simplify, so 16 minus, and then in my absolute value bars, I'm going to take -8 plus 1, and I get -7. And so now, when I rewrite this, 16, it's going to be minus, and I'm going to take what's in the absolute value bar, whether it's positive or negative, and when I take it out of the absolute value bars, it becomes positive every single time. So I'm doing 16 minus, and the absolute value of -7 would be 7, and now I'll finish. So 16 minus 7 is 9. All right. You have a you-try problem here that you can work through to continue to practice with this concept. The next part is talking about margin of error absolute value equations, because margin of error is really kind of an example that maybe you see. So if you ever see something that's saying like plus or minus this amount, that's when they're talking about absolute value. All right, so you can notice here, this was just an example of, a type of book that was really popular, and they're showing that, it's 50 people like it plus or minus that amount. So you could have anywhere between 47 all the way to 53. And you're showing that the distance from 50 is 3 one way and 3 the other. Okay, here are 3 different types of absolute value sentences. We're going to focus on this sentence only during this lesson. Later on, when we get into inequalities, we will bring up this same concept again. Okay, so if we flip the page, we're saying, let's try this problem out. So if we have the equation, the absolute value of x equals 4, this is telling me that I'm trying to figure out what value could I plug in for x that would produce 4, okay? So this means that the distance between 0 and x is 4, because absolute value, remember, is working with distance. So if we're trying to figure out the distance between 0 and x, and we know that it's 4 units, that means if 0 is here, I can go 4 units to the right, or I could go to 4 units to the left, because it's showing distance. So if the absolute value of x is 4, then x could equal -4, or x could equal +4, because I'm going to just take that negative value and plug it in for x, or take this positive value and plug it for x. So for this one, your solution, notice how you would get 2 solutions. So when we're solving with absolute value, we're always going to get 2 solutions. So for each absolute value equation, you must consider both cases. To solve an absolute value equation, you first must isolate the absolute value on one side of the equal sign if it is not already by itself. So when we talk about these 2 cases, we're talking about this area within the notes here. So case 1, the expression inside the absolute value is positive or 0. Case 2, the expression inside the absolute value symbol is negative, because remember, everything that we're working with is inside the absolute value, and when we take them out, they're going to be positive. So let's go ahead and look at this first example here. So let's first set up the equation for when the absolute value, so if I were to take 2f minus 9, I would need that to equal a positive 1. So I'm going to set up the equation 2f minus 9 equals 1. All right, so that's my first case. My second case would be that I could also have 2f minus 9 equal negative 1. And the reason why it can be negative is because, remember, I'm going to plug that back into the original problem, which if you notice, 2f minus 9 is in the absolute value bars. So when I take the absolute value, I will always get a positive value. So this is my first case. My second case is 2f minus 9 equals negative 1. So now, here's how I'm going to get my two solutions. So I'll go ahead and solve. So notice how I get two solutions. Something that you want to make sure that you always do, and we've talked about this before, is checking your answers. So let's say I were to plug 5 back into this original problem. 2 times 5 would be 10. 10 minus 9 would be 1, and if I take the absolute value of 1, I get positive 1. So that one works. With 4, let's plug that in. 2 times 4 is 8. 8 minus 9 is negative 1, but then the absolute value of negative 1 is 1, so that also works. So on your number line, you are just going to do this. Make sure that you have a range of numbers that will fit all of the, within the range that you're given. So I'm just going to start with 0 and just work my way up. All right, and really all you do is you're going to just plot 2 points. One of them at 4, one of them at 5. That's the only thing that you need to do as far as providing the answers. The way that I want you to write your solution is you're going to use these fancy little brackets. I'm horrible at them, but you might get better at them as you practice. And then you're just going to write your solution. So when it's asking for the solution set, this is the notation that we want to see. Okay? Let's go ahead and try the next one. I'm really just going to set this one up for you, and then you can practice this on your own. So 3 minus 2r, the absolute value of those equals 7. So my first case, meaning that it would equal a positive 7. My second case, that it would equal a negative 7. And then you would solve. All right, and work your way through there. The one I want to check out right now is 2b. If you look at 2b, notice how it says the absolute value of 8n minus 6 equals negative 1. Well, we need to really think about this because remember, when you have absolute value bars, when you take the absolute value of whatever is inside of there, it should always come out to be positive, okay? So when it comes out to be positive, this is where you need to identify that there is never a case when you take the absolute value of something that it would be a negative answer. So for this one, it would be no solution. The only time that maybe you could have that negative 1 there is if, let's say for example, we had negative 2 times the absolute value of 8n minus 6 equals negative 1. Well, remember, the first thing that we need to do is up here at the top, to solve an absolute value equation, you have to first isolate the absolute value sign. Well, if we look here, that expression with the absolute value bars around it is not isolated. So I would first need to divide by negative 2. So now if I take negative 1 divided by negative 2, I get a positive half. So now I'm showing that I would take the absolute value of 8n minus 6 equals a half, and then 8n minus 6 equals negative a half, and then solve from there. The next part is just working with using a word problem and doing the same idea. So it says Tara uses the elliptical cross trainer at the gym. Her general goal is to burn 280 calories per workout, but she varies as much as 25 calories from the given amount. Find the maximum and minimum amount of the calories. So if we know that she typically burns 280 calories per workout and it varies, this is telling us that it's plus or minus that amount. So I could add 25 calories or I could subtract 25 calories. And then this would give me my range of what she could burn on any given day. So if I add these together, I would get 305. And then I would get, if I subtract them, then I'm gonna get 255. Okay, so for this one, they're just having you find the maximum and minimum given the situation. The next part that we're gonna do is actually writing absolute value equations. So steps to write the equation involving absolute value for the graph. The first thing you need to do is you need to find the midpoint. And the midpoint is the very center spot in between the 2 points that are provided. Okay, midpoint you can almost think about average. If you add these two numbers together, divide by 2, you would get the same exact thing. So if I have 11 and 19, add them together, I get 30. 30 divided by 2 would be 15. 15 is my midpoint. Okay, so when we're working with this, now what we would do is figure out the distance from the midpoint. So knowing that 15 is the midpoint, my distance from 11 and 15 is 4. And then from 15 to 19 is 4. Notice how they are positive values, okay? So your equation would be to represent this, and this is as simple as it possibly can be. Your equation to write your absolute value is right in here. X minus the midpoint, and you're taking the absolute value of those, equals the distance. It is always X minus the midpoint, unless your midpoint ends up being a negative number. Then you would have X minus a negative number, which really means it would be X plus the midpoint. All right, let's go ahead and practice these two problems. So if we look here, we're going to find the midpoint between -2 and 6. If we add them together, we get a +4. Divide that in half, we would get 2. So 2 would be my midpoint. So I already have the absolute value of X minus 2. So X minus the midpoint equals, now I need to find my distance. Well, from -2 to 2 is 4. From 2 to 6 is 4. So that is my distance. Same holds true here. We have -9 and we have +3. If I take -9 plus 3, I get -6 divided by 2, I get -3. So now it's X plus 3 because it's normally X minus, but since my midpoint is -3, that makes it into plus, equals, and then my distance, -3 to 3 would be 6, and then -9 to -3 would also be 6. Okay, there's a you try here for you to go back and work with the problem here to see if you can come up with your equation. Good luck.